All right, everybody. So in this video, I'll continue to work some problems with u-substitution, but I've given you the preliminary explanation and the introduction to the method. I'll go through it a little faster this time, okay? But let me start with running through the guidelines real quick. So the method of u-substitution is to evaluate an indefinite integral, okay, that is more complicated than our rules would allow for. All right. We substitute the original variable. We substitute the differential. And if we do that correctly, the basic rule becomes applicable. Okay. All right. So let's look at a few more examples and I'll refer back to what I just told you there with those guidelines. So here's another one. Here's one that as we look at it, then we think, could our basic rule, which is like this, it says the antiderivative, the indefinite integral of x raised to some power n dx is x to the n plus 1 power over n plus 1 plus c. Could this rule apply to this? But this problem just looks so much more complicated than this rule would allow, okay? So the substitution would take this and reduce its complexity down to the point where this rule would be applicable. So one way that I might look at it is, I know that I always need to see the exponents of things in order for this rule to be applicable. So here, like with this fraction and this thing down here that's got that power in the denominator, that's not really the way that I need to see it, okay? So I'm going to do like this. I'm going to say instead of p minus 2 divided by this expression, it's p minus 2 times. Okay, so p minus 2 times p squared minus 4p to the negative 9 power dp. Okay, now we choose some aspect of this to be our substitution, right? So I've got to choose what the substitution is. I'm going to introduce this variable u, and I'm going to let that be substituted into the problem. But it has to be done in a way that this reduces to that. So you might think, there's lots of stuff here. What do I choose? I could choose p minus 2. Maybe this thing is the thing that gets chosen to be substituted, okay? But you might think about it like this. If this is going to reduce down to where that rule is applicable, it might make the most sense that the thing that has the power is what you choose for your substitution, okay? Now, that's not like a written in stone rule, but it's one that'll work most of the time for us, okay? I'll tell you another way to think about choosing which part of the problem is u, all right, in a minute. But for now, I'll say, well, how about this? Let me show you how this works out. So I'm going to choose that part. Now, remember, we don't just substitute the variable, we also substitute the differential. So it's like the variable is whatever it is. It might be A, B, C, X, Y, Z, whatever. You got the whole alphabet. We substitute that away, but that differential has to be also substituted. So here's how we do that. To substitute, now this will take care of p, the variable p. The dp, the differential, what I need to do there is take the derivative of both sides of this. So on the left-hand side, derivative of u will be du. On the right-hand side, I've got p squared minus 4p. So here I get 2p minus 4, okay? So there's your derivative of p squared minus 4p, 2p minus 4. But dp, that's a p derivative. Now, the goal is to substitute this. This method is called substitution, meaning that all the stuff that's up here, I need to substitute this in its place so that the variable is no longer p, but it's u, okay? So one of our other guidelines with u-substitution is the substitution must completely eliminate the original variable. So I've got to 100% substitute all the p and the dp away and get everything in terms of u. So this like sort of looks like it fit, but not exactly. So let me rearrange a little bit. Let's write this p squared minus 4p to the negative 9 power. Okay, I'm going to write this p minus 2 next to the dp. Okay, so that says, let's see, let's do like this. See where I'm going. So this will be u to the minus 9 power, and that will be like our rule. But what about this? Can I get this to be du? I mean, because that's the way it's going to need to be for this rule to become applicable. Do you see right there? Do you see 2p minus 4 dp? No, I see something close. I see p minus 2 dp, but close is not good enough. All right, it's got to be just like it. So let's see. I got to make both these things fit. Here's how I can do it. This is an equation, remember. Can you do something to this equation, such as add, subtract, multiply, divide the same number on both sides to make it appear this way? Is that possible? I think so. Like I could divide this entire equation on both sides by 2. That would do it. All right. And let me show you, like I get du over 2, and 2p minus 4 all divided by 2 is going to be p minus 2 dp. So yes, between this and this, I can complete the substitution. All right. Okay, let me do a little bit of updating. So it's my du question mark. Yes, I'm able to get it. All right. Okay. So let's see. In this step right here, between these two substitutions, here's what I will get. I get u to the minus 9 power, right? P squared minus 4p minus 9 right there. And then p minus 2 dp substitutes as du over 2. Okay, all right, now that's what I wanted to get. What about the over 2? Well, this du over 2, these are just 3 numbers multiplied together. If you were to read these numbers separately, it'd be u to the minus 9 power. That over 2 would be a 1/2, and then you'd have du. So you could just factor out that number. That's a 1/2. And then we can solve this problem with what? What was the goal from the beginning? To use our basic rule. Oops, I need to put a question mark. The goal from the beginning was to use this rule. That problem is complicated. It is too complicated for this rule to apply. But now I've made my substitute. I chose and I made my substitution correctly. Now it's not. Okay. So let's see. Here's what that rule says to do. The antiderivative of the indefinite integral of u to the minus 9 power. I will add 1 to that power, and I'll get the minus 8 power. And then I'll divide like that, right? And then I add plus c. Okay, and clean this up a little bit. Let's say this will make this term negative. So negative, I'll get a 16 on the bottom because I got a 2 and an 8. And then I'm going to put u to the positive 8 power plus c, right? That u to the minus 8, I'll send it under the bar. And one last step in order to get my original variable back, I will do this. U is identical, one and the same thing with p squared minus 4p. So my final answer will be negative 1 over 16 p squared minus 4p to the 8th power plus c. Okay, all right, there you go. Now, you don't have to write it this way as I have it. I mean, with any problem I do, I could probably write the answer 2-3 different ways. And I try not to take up time by showing you that there are 3 different ways I could write an answer. But you could write this way, but you know, just in case you should run into it, or just in case you're curious, this would be the same thing, right? I don't really think it's going to matter on my math lab or however you might be doing the homework, but just in case, I'll show you both of those. All right. So now look at what I did there. All right. And see, did I go through the guidelines? Did I choose a substitution that would allow the basic rule to apply? Did I completely eliminate the original variable? Okay, those are the basic ideas. Now, one more thing about choosing this substitution. When I started this problem, I said, you want to choose it so that this complicated problem reduces down so that that rule applies to it. Okay, and that's true. I mean, ultimately, that's what you want. Another way that people think about choosing the substitution is out of all the stuff that you see here that you could choose your substitution to be, you want to choose it to be the thing such that if you took the derivative of that thing, you would get the other elements of the problem, perhaps with some constants being different. So let me show you what I mean by that. For me to choose u to be p squared minus 4p, that makes this part u. What are we going to do with the rest of it, though? Okay, well, look what happens if you take the derivative. You take the derivative of this to substitute the differential, you get 2p minus 4. Now, that's not exactly this other thing that's left over, but all you have to do to make it be that other thing is divide by 2. And then that allows the substitution to be complete. Okay, so that's another way that people sometimes think about this. Let's try one more. What about this one? All right, r times r plus 1 to the 6th power dr. Okay, so the goal with this one would be the same as it would be for the other one, that I just want to make a substitution so that this basic rule applies to it, okay? I think that most people would look at this and say that the thing that has the power is probably what you want to choose for u, okay? Because that seems to make the most sense if you're going to boil it down to this rule right here being applicable. So of all the stuff that I see in this problem that I could choose my substitution for u to be, I will choose it to be r plus 1. Okay, now I choose that substitution. What's the next step? So that's your variable. That's how your variable r is going to be substituted away in terms of a new variable that will simplify this problem, u. The next step is to take the derivative of both sides of this to incorporate the differentials dr and du. They have to be substituted also. So derivative of u is du, and derivative of r plus 1 is actually just 1. Okay, so the derivative of both of these expressions is 1, but we always keep track of the differentials. So this is 1, but it's a u derivative, and the derivative of r plus 1 is also 1, but it's an r derivative. So we get both of these to work with. All right, now, what is the goal from here? To make these substitutions fit up there. Okay, and so far it looks like I could do that. Like look at what I have. This part right here, this will be u, okay? R plus 1 is u. But the dr, that will be du. So it looks like, right away, the things I chose for substitutions will have places to fit up there. I can put them somewhere. But look what happens if I do that. This is left over. I get r times u to the 6th power du. Okay? And that won't work. All right? Here's the reason. When it comes to doing math, we either solve this problem with the variable r, and if we don't like it that way, then we can substitute another variable in and solve it in terms of that other variable u. But a mixture of both is not going to work. Okay? So here's my guidelines up here. The substitution must completely eliminate the original variable. Totally gone. All right? So like I need to find a way to do that. So I need this to be all in terms of the variable u. Now it's a mixture. So, but look, I mean, these are equations. You can treat them like equations. You can add, subtract, multiply, divide the same numbers on both sides, right? Is there some way that you could use these equations? These are the substitutions you're working with. Is there some way you can modify them to substitute away the r and get this completely in terms of u? I could take this one, you know, if you want to substitute away the r, and I could move the 1, I could subtract 1 from both sides, right? And it would say r is equal to u minus 1. Well, that would work, okay? That would substitute this away. And then I would get something the basic rule would apply to. All right, so let's, one more step. We'll say r is u minus 1 times u to the 6th power du. Okay, now that still seems a little bit beyond where our basic rule could be applicable. Our basic rule is, how do you find the antiderivative of a variable raised to a power, like x to the n power? Like in here, we reduced this one to be just u to the minus 9 power. Like that's the kind of thing we wanted. This still seems a little too complicated, but here's what we could do. We could use some of our other rules for this sort of thing. Like if I multiply all this together, if I distribute this u to the 6th power, then I'll get u to the 7th power, and here I'll get u to the 6th power, and du. Now, there are some other rules for indefinite integrals that I mentioned in earlier lessons. One of them is if you have an indefinite integral of one function, one formula, plus or minus another, okay, then you could solve the first one, and you can solve the second one, and then you could add or subtract whatever the answers might be. So like the fact that there's this minus here, now that I've distributed, it's not a problem. This is the antiderivative of u to the 7th power du. And then separately subtract the antiderivative of u to the 6th power du. So if I use our basic rule on those in this manner, then I get u to the, that'll be an 8th power over 8 minus u to the 7th power over 7 plus c, okay? And my final answer is going to be, well, okay, so for u is the same thing as r plus 1, so I'll get r plus 1 8th power over 8 minus r plus 1 7 power over 7 plus c. Okay, and then that will be it. That one was a little different than the others, but still, like, we start with our basic choice of substitution, and then if we have to modify those equations somehow to make everything fit, then we do that, and from there we can get it to work.